Today, I would like to talk about our project, which is an air depolluting system that can reduce indoor and outdoor air pollutants and thus potentially improve people's health. So this is a passive system, meaning that it does not require any power to operate. We attended the National I-Corps program with this project in the summer of 2020. Here's our team. Keki and Dante are the entrepreneurial lead, myself as the technical lead, and Thomas from Little Architecture Consulting Firm as our mentor. Just to provide the background for this project, here is a real-time map showing the outdoor air quality. We can see that the particulate matter in the air is quite high in most big cities. It looks particularly high along the West Coast in this image because it is rush hour for the West Coast when I capture this image. The particulate matter in the air can be mostly attributed to fossil fuel combustion, such as exhaust gases from vehicles. This graph shows the result of a study published by the EPA showing the indoor VOC concentrations. As you can see, all buildings contain certain level of indoor VOCs, and some of the VOCs are carcinogenic. The goal of our project is to find a sustainable way to remove these pollutants from the air. These images show a bit more details about the technology of our project. So first, we coat the titanium dioxide on the surface of the buildings. And when UV rays with a wavelength shorter than 385 nanometers hit the building surfaces, the titanium dioxide molecules gets activated and generate hydroxyl radical through photocatalysis using the moisture in the air. The hydroxyl radical are very reactive, and it can react with many chemicals in the air, such as nitrogen oxides or VOCs. This technology can be applied to either interior or exterior of the buildings. When applied to the exterior, the facade can turn the nitrogen oxides in the air into solid nitrate deposits, which can then be washed away with the rain. So this can reduce the particulate matter concentration for the outdoor air. When applied to interior, the facade can break down VOCs into carbon dioxide and water molecules. Since the concentration of VOCs are usually very small, under 100 ppb, we can barely notice the increase of a CO2 level increase, in case you are concerned about the CO2 increase due to this conversion. So one pivotal moment in our project was that we started with promoting outdoor applications, which can reduce smog and clean the outdoor air. But now we are more focused on indoor applications. As we interview more and more people, it turns out that investors want the most bang out of their buck, obviously. So they would apply the interior to benefit the occupants in the building. We worked on small prototypes to understand the relationship between the air cleaning efficiency and some critical design parameters, such as surface area, UV ray radiation intensity, incident angle, and airflow speed like that. We're now planning to conduct experiments to benchmark the performance of our system. We have an airtight chamber built with various gas sensors and a data logger in it. As the UV light turns on, we can monitor the reduction rate of the harmful gases in the chamber. I hope this can provide a bit of benchmark for the air cleaning efficiency of our system. So when I interview those potential customers later, I can talk about the performance and they'll have a bit better idea what they are paying for. So for the next step, we're looking for partners that can work with us to perform titanium dioxide coating. Could be national labs or private companies. Also, for the next stage funding, we're planning to apply for SBIR or STTR from the National Science Foundation. So this is a very brief introduction to our project and our future plans. Thank you.